So before I start theoretical part, and actually it will be holding. To save time and to be more productive for your homework, I sent you a link here, which you may decide will be needed for you. And from this website you may want to download this file. And because it may take some time, that depends on how fast connection to internet from your computer is, you may do this in background. Any questions, comments on that? So I assume that there is no questions or comments. We will continue where we interrupted previous session, a little bit more details about data formats, which may deepen your understanding about documents and data, and then I will explain and show some demo how simplified computers work, and I expect this will take approximately first half of today's session, and then on second part of today's session I will explain you what you should do and how you should do it for your homework. So now about data formats. I already briefly explained it to you in previous session, but we ran out of time, so therefore it was very brief and probably not explained well enough. Everything in computer is just a number, and it is easier for electronic devices to count these numbers and represent these numbers with base of 2 or just 2 digits, 0 and 1, but meaning what these numbers represent is very different in very different cases. When we will talk about multimedia, then of course these numbers may represent sound and pictures together in video, etc. But the simplest way what these numbers may represent, they may represent characters. And character is bigger abstraction, and it takes together different things. First, any letter you can write as a character. Any Japanese syllable and Arabic syllable and Chinese character is also character. Then character may be actually representation of numbers as a text. A different kind of punctuation marks, like exclamation marks, semicolon, full stop or dot, call it whatever you like, and some specific purpose characters, and some of these characters may not even be seen on screen. And if you have enough time, I will show some demonstration for this as well. And particularly for numbers, numbers are stored differently than characters because purpose and meaning for number is to make calculations easy and fast, like adding, subtraction, multiplication, division, but we enter these numbers still like characters, but then internally they are converted to completely different data format, which is intended to store numbers instead of characters which you read, write and print, etc. And when we talk about numbers, then we print these numbers as characters, but that is only for demonstration purposes. Internally, for computation and for saving data, numbers are stored and handled completely differently than characters. And some of these characters may be printed out on screen, so you can see them and do something with them, but some of these characters are actually specific commands used inside network transmission, inside computer control, etc. And these may actually not be seen, but still are stored in files or in memory of computer, and these are part of all set of these characters. And standard way how these characters are organized is standard called ASCII, developed by American National Standards Institute. And what it actually standardizes is numbers, binary numbers, where only 7 bits are considered. But because computers like to have numbers grouped at least in 8 and then some multiplication of 8 like 16, 32, 64, then this standard actually describes well only half of all possibilities of 255 characters, precisely 7 bits. And that means that one half of this 8-bit code is well standardized and is de facto standard how these characters are stored, transmitted and handled. And other half is heavily dependent on different extensions of this standard, and approximately 15 years ago there was quite a big mess how exactly this second part of these characters was standardized, but now it is more or less organized, and I will explain how this organization is done. So here in this ASCII table we see 127 characters in this table, many columns, decimal value of this number, hexadecimal value of this number, octal number of value, mnemonic representation of it, and short explanation of it. And first characters with value starting from 0 till to 31 in decimal are all different kind of control characters. Most of them, if you will use them, will not be printed on screen, will not be printed on paper, but they may do funny things. For example, vertical tab, of course, may align your numbers following this vertical tab. Backspace actually will delete some of characters, and then there are other things as well. This actually is inherited from computers and devices from telegraph era, when these were used to communicate using telegraph approach between computers. So what you can actually see on screen, this character starts with decimal number 32 or hexadecimal 20, and first is still not visible, but it's very useful, it is just space in your text. Then different kind of punctuation marks, exclamation, double quote, blah blah blah, then numbers, other punctuation marks, then capital Latin letters, some of different kind of brackets, underscore, some other things, lowercase characters, another kind of different brackets, and another not visible character called delete, and it is actually different than backspace because backspace deletes on that direction and delete in other direction. So this is well standardized, and all other extensions of this ASCII table are almost always still compatible with this schema. But if we will look on these characters in binary, we will see that this last character 127 in binary would be 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 1, 1, 1, 1, 1. But if it starts with 1, and then some binary numbers here, then, as I told you, it was quite a big mess some 10-15 years ago. It could be used as extended Latin characters, Baltic characters for Latvian, Lithuanian, Russian, etc., etc. And because everything should be stretched into these 127 characters, it was quite a challenge. You could do this for most of these letter-based writing systems, but couldn't do it for syllable-based writing systems and word writing systems like Chinese. And also what resulted is a concept called mojibake. And this mojibake comes when you look on some encoded text using wrong encoding pattern. And how they dealt with that, they introduced another standard, and you can look on xkcd.com about problems with standards. That problems with all old standards are always tried to solve by introducing new standards, and then you usually have one more competing standard. But leading de facto standard now is standard called Unicode, which comes from Universal Coded Character Set. And it's maintained by an organization called Unicode Consortium, developed for worldwide use. Currently it has standardized approximately 150,000 different characters. Biggest part of that, of course, are languages which uses wording or word writing system like Chinese. Quite a lot of emoji also are there. And in theory, this standard may be extended to handle 2 in power of 32 or approximately or precisely 4 GB characters, where E means power of 2, not power of 10. But of course they have not used this entire space here. And then what is also important is that encoding how these currently standardized 150,000 of characters can be organized is actually can be encoded in different ways. And here standard called UTF comes into. So when we talk about these different kind of characters, we talk about Unicode standard. But when we actually look on transmission of files through the network, saving files on hard disk of our computer, etc., we actually talk about standard called UTF, and UTF comes from Unicode transformation format. So what you talk about here is actually transformed in different ways, and you need to know only 3 different ways. Actually, most commonly used is UTF-8. Why it's used? Because it's compatible with standard ASCII schema. That means if you look on bytes and their value is 0, something, something, something till to the end of the byte, it's still compatible with these Latin characters, control characters here, etc. Only problem is that UTF schema is so-called multi-byte character encoding. Latin letters which can fit into this ASCII table takes only 1 byte, but other characters may take 2, 3 or up to 4 bytes. In theory, this schema may be extended till to characters which are 6 bytes in length, or 2 GB bytes of characters. So problem with UTF-8 is that in theory it cannot describe all possibilities of 4 billion in binary. Characters, which is a little bit more than 4 billion in decimal system, but only 2, so it's twice as small number, but of course there's still enough free space to extend this encoding system. And then there are other encoding systems, UTF-16 and UTF-32. And these numbers here shows actually what is shortest possible length of character. For UTF-8, its shortest possible length is 8, but maybe in bits. This means 1 byte, but maybe also 32 bits or 4 bytes. UTF-16 means 16 bits or 2 bytes, and UTF-32 means 32 bits or 4 bytes. But both of these are not compatible with ASCII schema, and usually these are used only when you need to look on these characters as numbers, because these are fixed lengths, either 2 bytes or 16 bits or 4 bytes and 32 bits. So how UTF encoding works? UTF-8 encoding works in such way that if some byte starts with binary value, first bit is 0, then it is standard ASCII character. If its first bit starts with 1, then it's not standard ASCII character, it is extended ASCII, and it extends it in following way. That second one here says how many other bits needs to be read to complete one single character printed on paper or screen or whatever. If it starts with 110, then second byte, which starts with 10, also represents another part of value of this character, and actual value is encoded in remaining part of these bits. Then if you need 3 bytes, so larger value should be put here in these x's, in free spaces of bits, then first byte has value 1110, and then it says 3 bytes in group should be read to represent single character, and then you have free space as long here to put other data. And if it starts with 1110, then you need to have to read 4 bytes just to represent one single character, and this another 3 bytes starts with 101010, and similarly you can extend it for 5 bytes if you will need 1110, and then 4 bytes starting with 101010 and something, etc. So how does it look in practice? here we have simple plain text with extension txt. This means inside this file there is only text without any additional formatting like bold, italic, understroke, whatever. So every byte or group of bytes just represents character. And here, for these writing systems where you write it either with letters or syllables, there are different kind of pangrams. And pangram is short text which represents all letters in particular language. English, Latvian, Russian, don't remember. So this is Arabic, this is Ivrit, and this is Chinese, Japanese syllables and Chinese, and this is not pangram. These are just most common Chinese characters. So, and this txt file may be opened with different kind of text editors like Vim. Each of them has their, but it is something from North Korean, I don't remember. So with different kind of editors, simpler editors, not so simple, but particularly for Unix system, one of editors is called Kate. And good thing about Kate is that you can switch encoding system for it, how you read or write files are easy. It has button with menus here, and you see that here I have these pangrams and characters shown properly because I have opened this file by default standard, which is UTF-8. But if I open it with something else, I got these mojobikes, because what you should see here is that standard Latin letters, which conforms to this ASCII standard, is still not broken. And for example, for Latvian, where it still uses quite a lot of Latin letters, it is not broken, but everything else is broken. And if I change to something else, again, why it changes to something like this? Because if I change this encoding to different schema, in general that means that it assumes that all these bytes which starts with one something inside them are actually the second part of ASCII table, which is not so well standardized. And because this is actually wrong, this extended part, then of course we see broken things here. If you look, for example, in binary data, and here I showed you already GHEX editor, here it shows each byte with hexadecimal values for them, and when it can see actual ASCII text, it also shows ASCII text here. But then, when it can't show any ASCII text, you don't see anything interesting here. But with different text editor like Gwim, with additional plugins, we can actually look on more details. For example, this character in Unicode is 004D, or in decimal 77, and with UTF-8 encoding, these zeros are actually not used. So it is saved as single byte. Remember, 2 hexadecimal characters or 2 hexadecimal digits represents value of single byte, because 1 hexadecimal digit represents value of only 4 bytes. So pair of these two represents 8 bits or 1 byte. So for those of you who do not understand, you will be able to review this lecture, and repetition is mother of knowledge. And particularly for this character Latvian ž, which in English is Latin small letter z with caron, we see that its value in this UTF-8 encoding is 017E, and that takes 2 bytes to represent. It's a single character just on screen. Here we actually see 2 different characters, one on top of another, but particularly for Japanese, we see that this Japanese syllable also takes 2 bytes to be saved into file or sent through the network or whatever. And this Chinese character, most of them are also just 2 bytes in length, but there may be also up to 4 bytes in length. So, what you need to understand and remember from this is that when you deal with simple unformatted text, what you see as a single character on screen, or even no character on screen, actually may be long string of bytes saved in document, and if you look on the strings of bytes wrongly, it was, for example, before UTF-8 encoding for Unicode characters was de facto standard. Usually you got these mojibikes also when you sent letters, because letters, emails, are also encoding different kind of standards, and if this standard is wrong, you see wrong characters. Now a little bit more details about numeric data types. So again, these numbers just take 1, 2, 4 bytes in memory, but because main reason for them to exist is to support numerical operations, their representation is different, and because of this different representation, features are different and problems are different. And there are 2 different types of numbers: whole numbers without fractions and floating point numbers with fractions. And I showed this briefly in previous session, but the important part for these whole numbers is that depending on programming language you use and features of programming language you use, these numbers may be signed or unsigned. For example, for unsigned byte, its value is from 0 till 255, because that's how many different values you may hold in these 8 bits. So you start with all zeros. This is 0 in decimal, and you end up with all ones, which is 255. But of course, in many cases you also need negative numbers, and decision was made that first bit in this will be showing sign. If it's 0, it's plus. If it's 1, it's minus. But without any modifications here, if you use just adding number or sign for this first bit in your number, problem you have is that you have 2 different zeros, negative 0 and positive 0. And that is problem because if you do different kind of calculations, you may need to jump twice through these numbers. And because of that, actually in computers they use different schema called tools complement, where particular number is, you subtract 2 from it, and then you invert all the bits. But for those of you who do not have arithmetic mindset like me, examples are much better. So biggest negative number in such schema is in looking in bits 1, 1, 1, 1, 1. This is smallest negative number, and biggest number is 1, 0, 0, 0. And then with signed numbers you can represent only half of different values, and for negative half it's actually bigger if you use this standard called 2's complement. That, for example, signed number which can store only 8 bits can represent from minus 128 till to plus 127. And then you can get different kind of strange problems with overflow. Because when you have the biggest possible number and add just 1 to it, it can't become bigger, so it actually becomes smaller. And particularly for signed numbers, it works following. So here we have simple program in Java programming language. You don't need to learn this language yet. It is only used for me as easiest one to represent, for example, overflows. And if we run it, we first create integer type, which means whole numbers, which can store 32 bits inside it, not only 8. And then I assign maximum value to it. And in decimal representation it is kilo, mega, should be approximately 2 billion something. And this is possible value, maximum possible value what this integer type may store inside it. And then what I do here, I hope that you are at least so familiar with this notation here. I reassign value of this variable to new value plus 1. And here it's, by the way, it's also printing out here in this console. So I add 1 to it and it suddenly becomes minus 2 billion something. And you see here it is minus still 2 billion plus or minus 1. So it's 1 larger than that one. Why it behaves in such strange way is because that's how numbers are stored in computer. Because first bit means sign, and this in binary was something like 0, 1, 1, 1, 1, 1, 1, 1, 1, 31 ones inside it. And then I added 1 to it, and in binary it became 1, 1, 1, 1, 1, 1, 1, 1, in, or actually 1, 0, 0, 0, 0, 0. So therefore it suddenly changed its sign to complete opposite. Yes, and of course we can write actually the shortest possible way would be something like this, if you like, or something like this, and this is the same. Subtract, add 1 to this variable and store its value, and this means subtract value of variable and store it. And if similarly, if we assign minimum value to this variable and print it out, and then we subtract 1 from it and print it out, we suddenly got positive number here. So that's about strange cases. about overflows for integer numbers. And then for these numbers where we need to store different orders of magnitude of numbers, like starting from very small numbers to very big, in computers these numbers are stored as a floating point numbers using scientific notation. What is scientific notation? This means that you have some primary value here with some precision, and then you multiply it with orders of 10. In positive number orders, this means, for example, in 10 of power of 5, this means, I do not know, 100,000. Or with negative sign here, it means divide by 10 in power of blah blah blah, so it becomes much smaller. So in scientific notation, you have to store 4 different numbers or things. First it is mantissa, or it is this actual value. Then you need to say what is exponent for it with positive or negative sign. Positive sign means you multiply it with some base in power, and negative means you divide it with some base and power of it. And then of course actual sign here. And in computer it looks something like this. Still sign is first bit of the number, which similarly 0 means positive number, 1 means negative number. Then here is this exponent as a positive number or negative number, which shows as I multiply with power of something or divide with power of something. Only difference is that for most of these numbers, these are power of 2, not power of 10, and therefore when you convert it to decimal numbers, which we more or less know, then precision is and range is not very precise in terms of power of 10, because for binary digits it ends up somewhere in between, like orders of 10. And then there is this mantissa, or this number which you will be multiplying with this number here. And for floating point numbers there is also different kind of overflows, and similarly to integer numbers you may get overflow for these floating point numbers. That means you may multiply or add one number with another which is out of range what you can represent with fixed lengths of these numbers. And typical value for total amount of bits for integer is 32 bits. Or in difference with integers, you may also get underflow region when you subtract something or you divide something, and with this particular notation, with so many bits you can use to represent actual value, this value actually becomes smaller than you can represent it with particular system. So particularly for floating point numbers you have 1 bit for sign, then few bits for this power, and few bits for this mantissa. And again, if you have every one here for mantissa, but for power you still have 3 bits, then it works pretty well. You add +1 here, this means something like 0, 0, 0, 0, 0, 1. So here it becomes like 1, 0, 0, 0, 0, but you can still increase this ratio times 2 in power of this power. So what you actually, how you lose precision, so you can add +1, +1, +1, but because you do not have more bits here to save value, you can still increase this value times this value in power of that value. So you just got bigger numbers and then you lose precision. For example, you never can have more than so many bits to represent actual value. But then you have everything here, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, and then you add plus 1. You can't increase power anymore, you can't add anything anymore, and then you get this overflow. And similarly, if you have very small numbers, this means power is negative power, and then you have this negative number which is, and I think this one or once, and then you decrease it, then you actually, it becomes 0 because you can't represent smaller number with this particular precision. And how does it look on computer? So here I have similar example for floating point number. We are not interested about internal representation of it, but we are interested about how this underflow or overflow happens. And if I assign value 10 to this floating point number, what happened there? Then we can print it out, for example, it's 10.0, and then we can divide it by 3, and we get 3.33333. No more 3's here, because this particular floating point number cannot show this 33333 in decimal system till to infinity, so it's only so precise here. But if we assign maximum possible value to it, which is 3 in 0.4 blah 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 in 10 in power of 38, and then we add 1 to it, here we see this floating point number overflow. We added just 1 to it, but nothing changed here, because with this precision it cannot show very large number, 3.4 times 10 in power of 38. This means 3.4 times 10 with 38 zeros at the end. So it can't show any difference between previously assigned value and this value just plus 1, because it's not so precise. And similarly, and then I actually added to these values, then it just said, okay, it is infinity in this particular resolution. And then I actually assigned minimum possible value for this floating point number, which is 1.4 times 10 in power of 45, or this means 1.4 divided by 10 with 45 zeros after it. And then I divided by 2, I just got 0 here, because again, with this precision, with so many bits I can store inside computer, there is no difference anymore between this value and that value. And if I do something stupid here, for example, divide by 2, then it says it's not a number. But different implementations may also say that it is infinity. But this is how these particular numbers work. And then, when you understand these things, then probably you will understand this joke about robo CAPTCHA. Do you have some questions or comments so far? I take that as no. So now about computer architecture. So this graph here represents layers of abstractions how we interact with computers. All computers are built using some physical phenomena which allows us to handle different kind of numbers in general. And as I told it in previous session, so currently all computers are using transistors as basics of them, and transistors work in such way that first they work as amplifiers, so you don't need much of strength for signal to manage this transistor to be switched on and off, and then when you switch this transistor on or off, which means either it allows current to flow through it or not allow current to flow through it, you can use it as a presenter of binary values, something like on is 1, off is 0, or maybe absolutely vice versa. So then you use different kind of materials. The leading standard here is semiconductors based on silicon dioxide, and then you have different kind of parts in this computer, mainly this processor or central processing and logical unit, different kind of memories, different kind of displays, different kind of connections. We will talk in more details about this later, and everything that makes our computer together, and that is our hardware. But nobody today interacts with hardware directly, because if you would need to interact with hardware directly, then you would need to know this binary data, and you should use something like telegraph key to enter particular bits in sequence to interact with these computers. And actually early computers actually were interacting with humans in such way that you used switches to switch on and off different sections of this computer to send some data into it. But modern computers use software on top of it, which allows to manage this hardware easier. And here operating systems come in, because when computers become general purpose computers, there are many things which many of applications which are using have the same needs and behavior, and everything which is common between different applications usually is put into this operating system. Again, we will talk in more details about this later. Then there may be different kind of libraries, frameworks, which allows you to develop networked applications, graphical applications, etc. But what we are actually using, we use computers through the application, and we use different interfaces, and again about that we will have more detailed talk, like textual interface and graphical interface, but that's how we interact with this. And this is another view which shows it a little different. So hardware is encapsulated, we can see it, but we do not interact with it directly, but we may interact with different parts of operating system and applications, which actually make some changes in hardware. And hardware, not strange, maybe that's because I'm reading it from external mounted disk. So I went more or less successfully till here. And hardware mostly is built in a following way, that we use this so-called von Neumann architecture, which is leading standard for these general purpose computers. So that means that even though you have hard coded and fixed central processing unit, which can do different kind of basic operations with numbers, we can actually do different kind of high-level tasks using the same hardware, because we can load into its main memory different kind of data. And so in this von Neumann architecture, this means, of course, there is no single precise cut between von Neumann architecture and other things. There are still some built-in features of processors, etc. The idea is following, that you can use input and load different kind of data inside this memory of computer. And depending what kind of data you loaded in this computer and then you execute it from this place in memory, your execution will depend on this data. If you loaded word processor there, then you will work with rich text documents. If you loaded binary hexadecimal editor in main memory, then you can edit data in different way. And then of course it has different kind of outputs, mostly display, but maybe printers, USB, etc. And then if we look on these hard-coded built-in features of central processing unit, what it can do. First, it can count steps, how many of instructions saved in memory were executed. Then it may have different kind of registers where it can save temporary data to do different kind of algorithms with them. And then it may have different kind of registers to deal with data. And when you want to interact with computer directly without abstractions and operating system, in general you need to prepare these instructions as binary numbers and save them into memory of your computer. But nobody today use that. They use so-called assembly language, where you write these instructions in obscure English text, and then you convert this obscure English text, like your letters and instructions, into these numbers, and then you load these numbers into memory, and then you execute it. So each computer actually works with so-called machine language, and machine language is just set of instructions, what number means what kind of execution. So if we have like 8-bit computer with 8-bit processor, so here we always can deal with 8 bits at once, and then each processor has many registers and connections to the memory. And when it reads some kind of number, like 0, 1, 2, 3, not 2, 3, but 0, 1, 0, 1, blah, 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 then here it can create some connection to this register here, and some data can go, for example, from this register with this connection to that register. So what these numbers for instruction actually means is which switch here is switched on, which switch is off, which switch is switched on here, which is switched off. And then of course electricity flows from here to here, and this means you can send ones and zeros from here to here. If you need to read something from the memory, again, it has many wires here together if it's 8-bit computer. 8 wires, and again, with these numbers you can read, you can just make different kind of switches to this thing, and this thing is called bus. Not as a school bus, but as a kopne in Latvian. And so then these switches actually change these behaviors. And typically, there you need to store several bits in memory for one particular operation. For this computer I will show you on screen. It needs 3 bytes by 8 bits to do something. First 8-bit number says what operation do you need, or what kind of switches you switch on and off to do something. Then another byte or 8-bit number is which register in CPU are you using, and register is just short-term memory where you can read, write numbers inside it. And third byte is, for example, address, which may be another register or value from memory you can read and write. And how can we visualize it? We can visualize it following. So here we have simple 8-bit computer implemented in JavaScript in web page. Real computers are much more powerful, and this is 8-bit computer, so it can deal with 8 bits at once or one single byte. And here it shows, for example, state of its central processing unit. It has 4 registers where it can store numbers. Then it has specific purpose register called instruction pointer, which shows value where you need to read next number from memory for execution. And then it also has stack pointer. We will not talk about this today. And then it has 3 different states. 0, which means if you compare numbers, for example, from register A to register B, and if they are the same, then it will set to 1 here. Or if something is, you add numbers, for example, 255 plus 255, or 255 plus 1, you need to carry a bit. For example, you know that actually overflow happened in this register. So, and if it's true, this means when you added these numbers in registers, you actually have to carry a bit. For example, you may create your program which works with much longer numbers, but then you do it with smaller operations with just 8 bits or single byte. And here is fault state or register, which says, for example, some wrong operation happened. For example, you divide by 0. And here it also has built-in assembly programming language. And as you can see, it is quite obscure. So it is plain unformatted text, where these machine code operations are, you need to remember, assembly as a programming language was created when computers and networks were slow, and you had to save amount of characters you need for typing. And because you need to type quite a lot of such instructions, because basic instructions which we'll talk about here is just following. Jump, which means start execution from here, move data from one place to another, increment by 1, compare numbers, jump and stop. And this is just store values in memory. And this is actually standard assembly programming language syntax, and everything after semicolon is just a comment. And what this program does, I will show it actually during its execution. So I have compiled it and I have loaded this compiled program into memory, and this table shows total amount of memory for this emulated computer, and it also has display, and it is standard approach how you print out something on screen. This part, which is shown here in gray, actually maps to the output of our computer, and here it can show value of bytes into this output. That means if I will write with my computer something in this cell of memory, I will see this value here as a character put here in output. And similarly, if that would be graphical interface, I would have much more points here and numbers, and instead of showing character here as an output, it would show just one color of my display, like red, green and blue for particular place. And so what happened here? First, this assembler converted this text into machine language, into these codes. And for this von Neumann architecture, also programs for execution are just data. And you need, for example, to remember value be string hello world, and hello world will be actually stored, and we have assigned a label to it here. So this hello starts with address 2, and it goes somewhere here. And for example, if we open some binary editor, in ASCII encoding, there is some garbage here. Oh no, this is not. Oh, it doesn't delete. So here is this representation of this as a ASCII text, but in hexadecimal this representation is 48, 65, 4C, etc. And you see this also in this memory of this computer, 48, 65, 6C, blah blah blah. So here is this value of hello world saved into memory of our virtual computer, and then it ends up with zeros as a terminator, because we will use this zero value to know that everything is printed out into our output. Then here, after this zero, we have label start with this address. It jumps, it should be somewhere here. And here, for example, move 1 byte from address hello to register C is this one step. But we will just now execute it one by one. So we jumped here on this address, that is in textual representation, this is this part. So here are all our data stored on computer. In this case, this is string hello world. And here goes on this execution. So our instruction pointer is in address 0f and it is here. And then when it reads instructions, in machine code it is 020206. But in textual representations this means move data or byte from place in memory starting with hello, and hello here is label, and label hello points to this place, and actual value here is capital H. And when we execute it, we have wrote first of this hello here in register C, and in register D we actually will point to place in memory here for output to write something in memory there. And then we step forward and we write it to output, and here we wrote byte with value 68 in hexadecimal. Actually we can change it to decimal if you like. And here we see output on the screen. So everything what we write here in this part of this memory will be shown here on the screen here. And then we go into loop, we increment value of C register by 1, value of D register by 1. So here we count how many characters we have processed from this hello world saved into this part of memory, and here we increment by 1 to print something in this part of memory which is used to output something. And then we compare register B with what we have in register D in this place, and that means we check how we reached this 0 or not. And if we have not reached this 0, we jump back and we continue. And we continue here. And now we are close to the end, and we compare value of B register, which is 0, with value of C register in this place in memory. Why it doesn't show where is 14? Now it shows. And then we stop at this execution. And what is important from this demonstration here? First, that for these von Neumann architectured computers, actual behavior depends on what you load into your memory. If I would load something different here in this memory, then of course basic operations what my processor could do, like copy number from this place to that place, compare numbers, increment number, decrement number, that means add one or subtract one, and some other things would be the same, but actual things what I could do and execute with this computer would be completely different. Also, it shows here that when you load this program in your memory, you have to say where this execution starts. And then you can see, for example, how this standard input-output works. In this place, if you want to have permanent output, like on your display, to see, for example, all these characters not once, but until they are changed to something else, then typical variant how you do this is you share some place of memory with some external devices. That means here, when you have this bus somewhere, if your switches are switched in following way, actually. What's that? So here is your CPU with all these lines together with them and with many registers. And here is your memory, and I will show it as just two-dimensional table. And in some part in this memory, it is connected to some external device here. In our case, here is, let's say, terminal emulator, because if we read 8 bytes from this place of memory, it will be shown as a character in this place in terminal. If we write something from here, it will show on our external device somewhere here. So there is, and if I write something in this place of memory, then of course something changes here in this. And for example, if I say write to output not this but maybe this, and first I need to assemble it. Then of course it just cleans up this memory. And when we will talk about security, this architecture is very great for general purpose computers. What is not so great is that because instructions here are just data, and if I say start execute these instructions from wrong place, like jump here to hello, assemble it, then my execution starts from this place, and I immediately got wrong number here in invalid register, because this particular number, because now I tried to execute as an instruction these 3 letters, capital H, lowercase e and lowercase l, or these 3 numbers, and in this particular processor it is invalid procedure because there is no such register, and you'll see here that fault switch now is set to true because I tried to execute invalid operation. I do not know, does it allows me to do something like this? To start execution from some different place. Still invalid register. And yeah, you will have this link to this place. You may try to run it by yourself and understand more general basics. But that's about basic stuff, how computers work. And so what is fixed in terms of what doesn't change for this one Neumann architecture? These built-in procedures, what our processor may do, and so these all processors may move data from place to place, either from memory to register of processor, or from processor to memory, or from memory to memory. You can start program for particular place, you can stop execution in particular place, you can skip to some instructions, you can do comparison and decide either execute next instruction or jump to something else. You can do arithmetic with integer numbers, you can compare them, you can do different kind of things. So these basic operations of course are built-in features, but how do you organize these features. Of course, actual behavior of high-level program, what it actually will do, will be much different. So in this simple computer, emulated computer on web page, it used only 8-bit numbers. So modern computers mostly work with 64-bit numbers. So in terms of calculations and arithmetic operations, they are 8 times more powerful. And of course, they have different kind of specific operations, which I didn't show you in this demo example. And also, they are much quicker than in this web page. For example, in this web page, you could execute it with 16 Hz. That means 16 cycles in a second. And so is it right now? Not jump to start. So this is maximum speed how this computer can work, because it can execute only 16 operations in a second. But modern real computers can do approximately 3 and something billion operations per second. And when you talk about computers and other things, you should know C prefixes. Kilo is 1000, mega is million, and giga is billion times. But dynamic memory is a little bit slower. So, and because of that, for example, if you can do some calculations only between register and register in your processor, then it usually works much faster than involving random access memory in your computer, because usually it is 1.5 to 2 times slower than your processor. And so random access memory today is usually in terms of gigabytes. This means you have many billions of 8-bit cells or bytes to store values into this memory. And it is random accessible. You can always read write for any particular place in memory, as I showed you in this virtual computer. And of course, there are some part which is only read-only memory or ROM. And ROMs usually are used, for example, to bootstrap your computer to read something from it. But I will tell in details about bootstrapping when we will talk about operating systems. So, in general, that is about basic principles how computers work and how binary data looks like when you look into details. Do you have any questions, comments? So this is not off-topic question. If it is topic for next half of this session about practical exercise, probably you already have understood that I'm not using Microsoft Windows on my computer, and I have not used it since year 2008. Because I think for my particular needs and purposes, Microsoft Windows is not best operating system to use. And when I will explain your practical exercises, you may find out that also, if your computer is powerful enough, you may decide to do these practical exercises inside virtual machine using Linux-based operating system. That's why I recommended for you to download this large ISO file in background, because if your computer is powerful enough, probably you will have less technical problems to do everything as I will show it on my screen, not in your MacOS or Windows computer. But because idea for this course is that we will use only freely usable open source software, in theory that means you can use any tool you like to achieve expected results for practical exercise. But if you are not fluent with different kind of applications and how to handle different kind of data, then probably it may be easier for you to just copy activities for what I will show you on screen. As far as we will have time, I will also to show how it may be done in Microsoft Windows operating system, but I will not be able to help you if you will use MacOS, because I do not have MacOS at hand and probably will not have. So, any other questions or comments before we make break? It is not mandatory. If you can manage to do everything remotely without these common sessions, then for me that's okay. Any other questions or comments? Okay, I take If no other questions or comments, then now about your homework on practical exercises. For me it was easier to make content on my website. On this link I already sent it to you in chat, and if somebody had to rejoin the Zoom session and this chat disappeared, I sent this link again. And first thing you actually need to do is to get access to official materials of the course in this website of Riga Technical University, and MII actually means, probably you know better than myself, but to get into this system you have to register into it. So it is new system, and can we say it to change it to English? So hopefully you will manage this even if you can't change it to English. And then, wait a minute, little bit. Okay, and then you should see something like this. So this will be official website for this course. And here is links to my website, how these homeworks will be organized, and what is important for you before you will get into this system. And that's nice that you think that getting into this system is the easiest part of this course, as you didn't see, but you heard it was not so easy for me. I will show in details later, but you also will need this username arts with password RTC702 to be able to upload files for your homework into my website. So that's one thing, and other thing is about your first exercise. So naming conventions following your homework will consist of several exercises, approximately 8, if you will want to get better result for your homework, and if you will do some useful task which I will consider is worth some credit point, you may get even 9 just for precisely completing your homework exercises. But in general these will be 8, and here is -1 or zeros, which will not be rated but which are preconditions for you to do this exercise. And then for each of these exercises there will be several tasks, usually 2, 3. In this particular exercise there are 4, but I think when these tasks will become more tricky, number of these tasks for each of exercises will become less. And in theory you may complete these tasks in any computer using any application or software or program you like, because everything what will be required here will be about open standards, because for each of these exercises you will need to upload some file, and format for this file will be well standardized. That means in theory you can generate particular format of particular file with many programs. For some of you who live into golden cage provided by Apple or Microsoft, it may be confusing to you, because you may think that you need Microsoft Word to create files with extension dots or .x, but it is just your assumption and what Microsoft likes you to think, because then you have to pay royalties to use Microsoft Word to edit these particular documents. So you may think that to deal with this particular of data you need this particular application, but because this format of Microsoft Office documents is so popular and is, even though it's proprietary, but it is well reverse engineered and well understood, you can for example use LibreOffice Writer, and also you can access these documents. And for example, extension TXT means simple unformatted text file, and of course this one you can edit with any editor you like, and in this theoretical part of demonstration I showed it to you that I opened this file at least with 3 different kind of editors. But probably you will find out that if course is not about using Microsoft Office, but course is about different multimedia files and binary files, as in this particular exercise, etc., you may find out that Microsoft Windows as an operating system actually do not provide you nice utilities how to do these things. So I think that Microsoft Windows and Microsoft Office is best operating system and best Office suite only if you spend 90% of your time using Microsoft Office applications like Word, Excel, PowerPoint. But if you spend more time something else using some browser like Firefox, Chrome or Chromium or Edge or whatever, and you do other things like me, then you will find out that actually Microsoft Windows together with Microsoft Office is not the best operating system and not best Office suite to do more technically challenging, more tricky tasks. And as I told you, I'm using Linux-based operating system. In this particular case, it's called Xubuntu or Xubuntu for English speaking and American speaking, because for them somehow X in front of Word becomes Z, like Xerox is Xerox somehow, which is one of different kind of Linux-based operating systems you may use. While using Xubuntu particularly, I may send you some links later if you are interested. And for those of you who are afraid that if you will try to use different tools, then you may not be sure that you will get expected result, then my recommendation is following: that I hope that all of your computers are at least younger than 7 years old, and that means in general you may run virtual system inside your computer. And actually, as you can see here, I have decided that particularly for Zoom sessions it's easier for me to share just part of screen inside virtual machine of my actual physical computer with native host operating system, because then I could see additional information, etc. And first I will explain what I think is a recommended way to do these things, and then if you will have time and you will have interest, I will explain with alternative ways which I do not think are so good. So I hope that you have downloaded installation file for this Xubuntu operating system, and I will tell you in details about different kind of operating systems later and why this particular operating system. But you also need to download application which actually allows you to run virtual computer inside physical computer. And probably most of you are using Microsoft Windows operating system on your computer, so you need to download this VirtualBox installation file, download it and install it. I can't show it on my screen because there is no virtualization supported inside virtualization. I hope that this will not be your first application you will install on your computer. And then you need to download that file. And starting from that place, we may see similarities. And I will shut down this virtual machine because otherwise my computer may become too slow to do all these tasks at once. And then you open this VirtualBox manager. And I have several created virtual machines inside this manager. These are entries to these virtual machines. But you will need to create a new one. and you can okay, so about these links. So these links you may get from this zeros exercise, but if you want to have shortcut, and probably for Windows, restart. So, I hope that majority can follow me, and when you get screen like this in Microsoft Windows, of course a little bit different, but idea is the same. We have to create new virtual machine in menu here, and I will call machine, where is new, add this. Don't laugh at me, I do not create virtual machines every day. Like cloud, something, maybe I have added something. I would say something like just new virtual machine. That's import, export, why it's cloud. New, this one, yeah. So to be sure, menu machine and new, or just Ctrl N as a hotkey combination if you do it frequently. And I will call it Xubuntu 1 because I already have Xubuntu created. Here will be a place where I will need to save persistent data of this virtual machine, and persistent data is just very high level abstraction. That means large file where all things inside this virtual machine will be saved as a large file in your physical computer. And I think you don't need to change anything here. Probability that your machine will be 32-bit machine is pretty low. And if you will have some strange problems and you have old computer, then actually maybe that may be problem that your physical processor is not 64-bit processor but 32-bit processor. So here you can put as much as virtual memory for this virtual machine as it is considered green. So that means up to maximum, but not more, that you are actually stealing memory from everything else for your physical computer. Here you have to create new virtual hard disk. Don't change anything here for its type. Don't change anything for this dynamical allocate. This means that actual size will be smaller than reserved size because this file will be increased dynamically depending on needs. And here it starts with 10 gigabytes to be pretty sure that you will not run out of free space. Probably you can change it to 20 gigabytes or maybe even more. Remember that if you will not need so much, then this file for this virtual machine disk will be actually smaller. And then say create. But that's not it. Only thing what we've done so far is following. I have created entry for this virtual machine called Xubuntu 1, and I have created some setting files for it, and I have created virtual disk which currently takes only 2 megabytes. but of course it will increase. But of course this disk actually is empty. If I will start this machine, nothing will happen because I need to load operating system into this virtual computer. And here this downloaded ISO file comes into play. We can do it step by step, and step by step would be splitting problem in smaller parts. There is entry in file Virtual Media Manager, which shows you all virtual media in this virtualization software. Different kind of hard disks, you should have one like this one here, and also optical disks. Again, I have several entries here, probably you do not have any, but you can add it and you point it to this downloaded Xubuntu blah 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 desktop AMD ISO installation file. It is not required that you do it step by step, because you can actually do it through the settings of virtual machine, but I think doing it with smaller steps is more complicated in number of steps, but then each of these steps is a little bit less complicated. And when you have done this, then you go into settings of virtual machine, like right click on settings, button settings, anything. And oh, it's so slow. And here you choose entry storage, and you say that you will insert virtual DVD disk inside this machine. So you go to storage and choose controller ID. You don't care about this. What you care about is this CD or DVD icon here. And now it's empty, but you choose it clicking on this icon here and choose vertical optical disk and choose that proper one from this. And if you will do it by try and error method, in Russian metodom tika, then you will see that you can actually put entry to insert this virtual DVD disk in your machine in very different ways. But what is important is that now we have defined or declared two different storages for our virtual computer. Empty hard disk located in this file and non-empty DVD disk from this downloaded ISO file. And then, if you are not afraid, we can do some optimization, and if you are afraid, you can skip this part. But what we can do in system, we can remove virtual floppy drive. We should add, if it was not added automatically, networking for this virtual machine. That's actually important. I'm surprised that this networking was not added automatically for me. Don't change anything here. For processor again, if you like, you may increase number of processors assigned to this virtual machine till it's considered green. No need to change anything here. But here for acceleration, you may choose non-standard, quicker way how this virtual machine runs. And default means that it will be a little bit slower but more compatible, so it should run all the time. But to make it a little bit faster, if you are running inside Microsoft Windows, you may choose Hyper 5 virtualization standard. This is physical acceleration for your virtual machine. I will not choose this because for me my native host or native operating system is Linux-based system, which is KVM from kernel virtual machine, something like this. So remember, if either do not change anything or use Hyper-V and hope that this machine will work, or if you are afraid, do not change anything. And then audio should be enabled, network should be enabled. I think that's okay for me. And we may try to start this virtual machine up. And what should happen here is that it boots or loads this operating system, how it starts, from this virtual CD DVD drive. If you see something like error, cannot boot up from empty place or whatever, then of course something is wrong with your entries for these external disks. And then you may choose different kind of languages for graphical interface. For this class I will choose English, and you may run so-called live demo. This means you can run the Ubuntu operating system without touching hard disk at all. And that's, for example, if some of you will decide to switch from Microsoft Windows to Ubuntu operating system as a basic operating system for your computer, you may burn this ISO image in DVD disk, and then you can try Ubuntu. It will load everything else from DVD disk, but will not change anything on your hard disk, and you will be able just to check that everything works, that the network works, display works with normal resolution and without any changes on hard disk. But because I'm brave and I know that this is inside my virtual machine, I will immediately choose install Ubuntu. And here you can choose your keyboard layout. For me it will be Latvian, but not with apostrophe. So for normal users of Latvian keyboard, probably you are using this Latvian apostrophe, where apostrophe is this single quote or key for diacritic letters. But I'm using this keyboard layout, so don't choose this if you are not sure. Just choose English keyboard layout if you are not sure. So I will not do this, because I will need to do some customizations. And here, do not freak out, because I'm doing this inside my virtual machine. Erase disk and install Ubuntu means that it will erase everything and will change everything in this xubuntu1.vdi file, which is used as a storage for emulated hard disk of this machine. So this doesn't mean that entire disk for your host operating system will be wiped out. It means that everything will be wiped out from this file in your physical computer. But of course, if you run it as a on native computer from external DVD disks, and of course this means that you start completely new life with your computer. So, not changing anything here and here. Okay, I will choose this username. And pick some username. De facto standard for Linux-like systems, base system or Unix-like system is all lowercase here. For example, here you may write your name and surname, and here just short name as a username here. And of course you require password login, even if it's virtual computer. So, if you are setting up operating system first time in your life, then you see that in general setting up operating system on computer is not different than installing some application. Only difference is that if you will set up it unsuccessfully, your computer will not work at the end because there will now be operating system on your virtual or physical computer. That's only difference. While we are waiting for this setup wizard to do its job, do you have any questions, comments so far? About deadline for homeworks, for me it is easier that all homeworks will be checked at the end of semester. That means that if for some reason you decide to leave everything for the latest possible moment, you may do this. When we will actually go into practical exercise, I will show you how you can get feedback that deliveries, which means different kind of files or exercises, are successfully uploaded to my website. But and usually students agree that this is probably best way for them, if you do not want to have interim deadlines for each particular homework exercise, then I will check everything only at the end of semester. And that means that your deadline is something like, I do not know what you consider end of semester, Christmas time. But my recommendation is to do this as soon as possible, because then you will have more time as a buffer to ask questions to me. Otherwise, if you will leave everything for last moment, then of course I will not be able to explain everything. And as I see from chat here, most of students agree that common deadline for all tasks at the end of semester is great. Usually setting up this virtual computer works faster for me, but it looks like Zoom session actually requires quite a lot of resources from my computer, and therefore this virtual computer works slower. If you are curious, you may see here, this is usage of all processors on my physical computer. Only problem is I lost but I still hope that we will manage to explain everything about first practical exercise in enough details. And also, connection to internet is now slower for my computer, because again I'm sharing this Zoom session with you. Okay, while we are waiting to this very slow virtual machine. Yeah, but I can't even open web browser. So question is why something is better than something else, and I have answered to this question to some of previous classes I have conducted, which is Java bootcamps. And this one. And particularly for Latvian. And we can update. What's this? My machine still running. And you will be able to look on them later through these links as well. Finally. So here it automatically ejected this DVD disk, what you can see here from the status line of virtual machine, and press enter to restart this virtual machine, and hopefully it will boot up and will start working. It may not work if you messed up something with settings for your virtual machine, etc. And then you log in. And then probably you may want to change display resolution to something better, which is display entry here. So default standard for them is that this taskbar is on top, not in bottom, and here is start button and here is start menu. And so here in settings in display I will still use quite low. For presentation needs this one. And then you may agree, for example, to add more complete language support. And while I'm waiting, so what is built in here? There is LibreOffice Office Suite already installed and Firefox web browser. So in general, in difference with Microsoft Windows, you don't need to install anything else to start simple office work. And here it has built-in software updater. I will not do it now because it takes quite a lot of time. And now I can open web browser and open this web page. What was code of the course? RTC something. And this website is case sensitive, so you need to know, and it is easily offendable system. It is sensitive, do you add slash at the end or not, and it also cares about uppercase or lowercase letters here in URL. So, and now we can start looking into actual exercise which will be rated at the end of semester. First, because for me it's not so easy to manage and know in advance what kind of identifiers you have in high school. In this course you will have assigned unique identifiers, just a large string of random characters. And before you do that, probably many of you do not know what terminal is, but terminal is one of things where Linux-based operating systems and MacOS including, because these both are Unix-like systems, and what is Unix I will tell you later, is that they have very powerful management system using just text interface. And why text interface is good? Because text interface is easy to describe, easy to automate, and easy to redo. And you open this text interface with terminal, and here it is, one of these favorites. And here you write commands, and when you enter them, these commands are executed. Pay attention here what I have wrote here, because I'm not using Latvian QWERTY keyboard layout, but I'm using Latvian modern keyboard layout. And in difference with Microsoft Windows, almost anything you need to do with your computer, you also may do inside this terminal. For Windows, if you are power user of Windows, you may have used terminal or this command window in Windows, but it's quite weak, and because of that you may think, terminal is just for some simple things, but in Linux particularly, terminal is very powerful. For example, I can run LibreOffice from terminal very easily, or anything else. And so you write words, and what does it mean? First word is command you will try to execute. For example, simple text editor in Xubuntu operating system is called Mousepad. So I can call it, and such text editor is opened. I can also say two words mousepad test.txt. Then two words in terminal means first it executes command and it searches where this command is actually located. So if it is found, then you can call it, and then you can write two words. You open editor, but then this word is used as additional information for this editor, and you see that now I have opened an empty file with path/home/student/test.txt. And I can write something here, and I can save it and close it and open it again, and here this file is. So first command is executed command and first word in this command, and all other words are additional information for this command. If you run some command which runs forever, like monitoring utility called top, then it runs forever until you press Ctrl+C. And because in terminal pressing Ctrl+C means interrupt continuously running program, for example, to copy paste here, you either right click with mouse and copy paste here with context sensitive pop-up menu, or you need to do different key combinations to copy and paste. First, in terminal and other Unix-based systems, there are actually two clipboards or buffers for selection. One is selection buffer, and if I select something, it's already selected, and with Shift Insert I can paste it. But I also, for beginners actually, I think easier is right click with mouse button, and then you can copy paste if it's easier for you to do this. So detailed things how you use terminal is under this hyperlink here. And so for me to get this quite unique randomly generated number as my identifier in this course, I didn't need to close it. I can copy it, and for beginners, copying, pasting into terminal of commands would be easiest one is right click with menu, copy here, right click here and paste here. And this will be my identifier. And to render it, I will save it. Let's say on desktop. And because this string is quite long, probability that you will get the same number is 1. I think 1 against a few millions or billions. But if you have not managed so far to use terminal, there are different kind of websites which allows you to generate random numbers. And actually this is number represented in base 64 encoding. Then you can use this website here. And do not try to generate it that it looks nice, because as nicer your string looks, as less randomness is there, and probability that you will have some clashes with other students is there. And so when you have done this, your first task in this exercise is to create plain text file, and you should know what plain text file is. Plain text file is with extension txt, which has only simple and formatted characters inside it. And in modern systems, if these characters are not Latin characters, then of course you should use UTF-8 encoding to save non-Latin characters. For example, if I want to save Aldis Vitoļņš, then of course it should be encoded in UTF-8 encoding. But in modern operating systems, this is actually de facto standard, so you may not even care about it. And what I can add here, for example, particularly for Xubuntu, you may use following text editors to get it done. And here in this system, you look on accessories, and these are small programs and utilities. So simplest text editor to deal with unformatted text files with extension txt is this mousepad text editor. I actually saved somewhere where was my identifier. And so content for this file is my name and surname. And I save this as this unique identifier, first exercise, first file.txt. And if you have some middle name, like You may add your middle name here as well. And that is easy part. You should be able to do with other text editors as well. And if we do our tasks step by step in smaller steps, we actually may submit first file for first exercise, double check that it is proper ID, one number, second number, txt. I think it's correct. Somebody wants to ask something. So we go here at the beginning of this page, submit files for exercises, and username and password here was, I don't remember, but I know where I can look. Arts. That's 702. And you can save this password. So browse for these files, choose this file, upload, and you should see that this file is uploaded successfully. So this is early feedback for you to see that everything is correct, but there is also another page generated regularly where it shows status of uploaded files for homeworks, but it is not executed all the time. You upload something, it is updated only at 7 o'clock morning each day, but for presentation purposes I will re-execute it again. And here, because every student uses the same username, the same password, for 8 letters of your unique ID, only 4 letters will be shown. And this is again, if you will actually use random number, not some pretty string, then probability is that these 4 letters will be the same for several students is very low. Why here only first part is shown? It is just against vandalism, because everybody, if somebody is crazy and not lazy, he or she may upload these files with this identifier, but then he or she will also need to check out what are all possible combinations for second part of this identifier here to actually overwrite files which were uploaded by you. So it is just a simple measure against mistakes or vandalism or whatever. So, and with that I have completed 1/4 of first task. Now we will have a little bit more tricky things, and if you use Xubuntu, then you can install particular utility bin-hex-ascii in command line. That's how this utility is called. With this command, and again here I could be more verbose. Of course it's in terminal, but if you are a beginner, then you may be surprised what exactly you should do here. And what this command does, so first word means executable command, and sudo means escalate your privileges to super duper user. Then, when you have done this, apt command is called, which is this package manager to install additional software on your computer, command install, and this is name of package. So these 4 words mean escalate privileges to super-duper user, call apt package manager, say install something to this package manager and install this particular package. Again, right, select everything here, copy and paste it in your terminal because this utility is not installed by default. And here, when we escalate this privilege to super-duper user, we have to write password of this user. Don't freak out, don't be afraid that you don't see anything. With my clicky keyboard you hear that I'm entering this password, but nothing changed here because it's old school standard coming from mainframe computers, and at that time when passwords and things which were private and secret were not shown on screen at all, so no any visual feedback like circles or stars, whatever. Just type this password and press enter. And then you can call this tool, not in this terminal, not in that terminal. And what this tool does, so this tool allows you to convert characters to hexadecimal presentation, to binary presentation, to decimal representation, to ASCII. And you call this tool, if you call it without additional information or parameters, it shows following help first error because not enough parameters, and you need to do conversion dash dash or minus minus in jargon. And so binary to decimal, binary to hexadecimal, binary to ASCII, decimal to binary. So these parameters means from which to which format you convert some string. And with this parameter A to B means from ASCII to binary, and here some string. I will not show everything completely to you. So, some string here. And it is converted into characters just 010101, and each of bytes is separated by space to make it a little bit easier to read. And here it actually requires is that each bit is shown as 0 and 1, and bytes are delimited with spaces, so we are happy with default output. And so either you copy or paste it, or okay, let's copy and paste it. And of course we don't need this binary out, we need just only these numbers here. And we can open our Mousepad text editor. Paste these numbers. And that would be file, first exercise, second task. I think it is txt in extension. And of course here you need to do for this particular string, which is also pangram in English. If it's not accessible to you, then we can use some web service here, and we need to convert characters ASCII text into binary. So for demonstration purposes we used which string? This one. Paste ASCII text here, and here is representation of bytes, and just for curiosity, I will save it as a separate file. You don't need to do this, this is for demonstration purposes. Mount is comparison tool to compare files or folders between them. And you see that these both files are identical. So I used two different approaches, but if I do it properly, then of course I get the same result. And if I do it part by part, I may upload my second file for first exercise. So third task is to decode, and here please remember nothing here is about encryption, it's about coding. This means what is written here in language you understand is written here in language which you probably do not understand, or at least do not understand well. So it is just translation from language to language or from presentation to presentation, but it is not encryption. Of course, if nobody understands what particular algorithm you are using to transform from one to other, it may be some kind of encryption, but it is weak encryption, because if you do statistical analysis here, you will see that, for example, these bytes represented here with just zeros and ones have the same statistical regularities as for English. So then anybody who knows something about encryption will understand that it is just English written in some different format. And here again, in second part, we need to do it in opposite direction. There is some string encoded in base 64 encoding, and you need to get this string back. But because I do not want to show you actual result here, let's use this tool here and say that from ASCII to here we need to use different tool, like base64. For example, we got string like this, which is the same English text, just encoded in different encoding format, using 64 different digits or characters. And then, if you convert them back, for example, use and base64 utility, I think is included by default. Because this is new virtual machine, I know it is. Base64 -d means the code, and we got this string back. So you copy this string and open mousepad and save it as a shared file for first exercise. And similarly, if you do not have access to base64 utility, you may copy this string here, and how we do decode it in this website. Maybe just paste it here and see what happens. Yeah, and then depending on where you paste it, it converts in all other, and we got this ASCII text back from this encoding here. Remember that for base64 encoding, what is very characteristic thing, that it has uppercase, lowercase characters and numbers, and if number of bytes you need to encode and decode is not divisible by 3, then you have 1 or 2 equals signs as a padding at the end. Nevermore, either nothing or 1 equal or 2 equal. For example, if I add here, I see here that probably line break was added at the end. So that's about third exercise. We can upload it if we like. And then fourth task is a little bit more tricky. We need to download this file. And again, I will not show what is inside this file, but I will show how this file is created. Inside here. And I'll name it with different extension. And then we may probably need to install some binary editor. ghex, as far as I remember, in Linux. But I will show that this is not only editor you may use. So here it's a ghex hex for Linux-based system and HXD, yeah, for Windows. And for example, for Microsoft, last time I checked, all associations between files and probable editors are just through the extension of the file or these last letters after dot in the name of the file. It is quite stupid thing because actually extension is just additional information, mostly for humans and for stupid applications, because in normal operating systems you can still open this file with simple text editor because it says that what is inside it is just a text. But these editors, which allows you to use wrong extension and open it, needs to analyze and check is this text or not. And if you open it with something else, like edit it into insert mode and insert here byte with value 00. So 00 is just 0 in hexadecimal notation because one letter may represent only 4 bits of the byte. And save it. And now it is not editable with our simple text editor mousepad anymore. And if I force it to open it, where is open with other application, choose mousepad, there it is. It is still confused. Why? Because it says invalid byte sequence or conversion input. In normal text editors, there shouldn't be bytes with value 0 inside them. So this is not TXT format anymore, and this editor refuses to open this file. If I try to open with something else, like LibreOffice Writer, which in general allows you to open text files, here it shows this text here, but if you will try to save it again, it will be broken because it converts this 0 bytes just to substitute character. But of course we don't need to edit and save this file here anymore. So, and in this file here, it's just obfuscated in such way that stupid text editors will not consider it as a text document anymore, unformatted text document. But there are different kind of utilities, like strings utility in Linux, which this is also need to be installed. Okay. Okay, you see, I tried to execute this command, but it was not found, but Ubuntu-based systems with this package manager are quite nice. They say that it should be installed, so it knows where this utility may be located also in these packages. And so I see, it extracts everything what is text inside this binary. For example, so LibreOffice is this program I run to open this rich text editor, but inside this program they also quite a lot of text inside them. And so here is all this, what is text in this program. So strings just extract strings out of any file you can pass to it. So and when you got out what is there, then you will find out that there is some not very tricky question and you need to get answer for it. And so let's assume your answer is your answer. And again, it should be obfuscated that simple text editors refuses to read this answer as a simple text. So what do? I will open this editor immediately under development, ghex. But this editor is bad. It always needs to open some file. One extension I think is bin. So first byte should be design. And again, remember, this is not encryption, it is just obfuscation, because anybody who knows a little bit more about different kind of utilities will see that it is not any encryption at all. But if you will try to open with some stupider text editors, then these are not openable. But there are other text editors which are smarter than Notepad or Mousepad. And I'm using editor called Vim, or for graphical interface it's Gvim. And you are not required to learn this editor, but it's not bad if you know about such editor. And this is much smarter editor than these Notepad-like editors, because if you have some strange file which has strange things inside it, you still can open it. And here it shows this specific symbol with this caret or whatever it's called, with specific thing. You may change it that these invisible symbols are not shown, but it shows here. This is some strange byte here, shown here is in specific way, and then actual text. And this is also first exercise or task for first exercise. Completed. And after they will pass, this utility will be run. Which regenerates entire report And you will see, for example, here, that for first exercise 4 files are found. And you can check that this looks completed, at least in terms of number of files required. So, is here need to show in general how you can deal with this force part using Microsoft Windows. We still have a little bit of time. Do you have any other questions or comments? It will come with feedback, will come with a cost, and here you need to, majority of class should decide. So if you want to get feedback that something is done, you will have gradual deadlines for each of particular exercises, because I don't like to review it more than one time. And then you will know for sure that this is done, this is not done, etc. But of course, you will get feedback at the end when everything will be reviewed. I will, of course, in one session, but I think that will be for this exams session time. One part we will... again, it depends on how you decide what the deadline should be. If you will decide the deadline should be earlier and you want to get feedback about your practical exercises earlier, I can review it and we can spend one of these sessions till to Christmas time to review your practical exercises. But then you will have a little bit less time to do everything. And but so you will get feedback and review, but it will be either last session till this semester ends, or one of these sessions for reserved time for exams. But it's up to you. You just need to decide. And not even majority is required. These who will have opinion, who will say it, what is better, I will accept that. Yeah, and of course, if you will do your practical exercises timely, when we will start next session, while we will waiting for these who join late to come up, we can of course always spend some time reviewing previous exercises, what kind of problems you have, etc. So starting with next session, we may also spend some time to review your problems. Then, of course, you should be prepared to share your screen, because it is much more time efficient to see what exact problem you have than just describing it. So, therefore, my recommendation is to do this timely. Then you may show during this discussion part what kind of problems you have and how we can deal with this. And what was called for this So here, if you still use Microsoft Windows, which is not so elegant for different kind of utility tasks, my recommendation is that you use this website. And here let's check. Where did they save this file? And actually it works pretty well. But if you try to open it with some stupid text editor, actually it works pretty well. But then you will not be able to properly obfuscate it, for example, if you use this Notepad text editor. So you probably need to download this utility, HXD. How do we get it? This should work for me. Why so many choices? Different translations. Where is English? Let's create new file. So zeros, bytes here. That's okay. And how do we write text here? Dot inspection. Maybe we can just paste it. So let's open. Only hex values. Then you need to convert these to the hexadecimal values. And how can you do this? Again, you may go to this website, and in hexadecimal it is these values here. And save it, and that would be like And that's how you do this in Windows. For this particular case again, you see that even such editor is not so, maybe I don't know how to use it, so easy to use than for Linux-based operating system. Because here we can't write it as a text. We have to write everything in hexadecimal system for these bytes. What will be checked here, of course, that your answer here is correct and that initial byte of this file is 0. And you cannot put it easily with simple stupid text editors. Either you need to use smart text editors like Vim or Gwim, or you need to use some kind of binary editors which allows you to put any byte you like here, but then of course this particular editor is much weaker as a text editor. That's about today's session. Do you have some short questions which I may answer with short answers?